Okay, so this is review day number 3, and I'm going to go ahead and start with number 1. We have log base 10 of 8 plus log base 10 of 3, and it's asking you to write as a single log. Remember, you're going to use a product property. You're going to use a product property. In other words, it has to have the same base. And you're going to multiply 8 times 3, which is 24. And that is a single logarithm. For number 2, you have 4 log base of 2 of x plus log base 2 of 3. What I'm going to first do is I'm going to condense it into a single log. So it's log base 2, and we're going to multiply 3 times x. That fourth power, the 4 on the side can become a power. So you're going to have log base 2, 3 to the 4th, x to the 4th. And that is the single logarithm. Number 3, we have 3 log, it's base 10 of x, plus 4 log, it's base 10 of x. So remember that 3 that's in front as a leading number there can become a power. So you have log x to the 3rd plus log, log x to the 4th. And then we can make this into a single log. So you have log x to the 3rd times x to the 4th, which this will become log, and it's base 10. It's going to be x to the 7th. So number 4, we're going to expand this. So we have log, and the base is b, and we have 2 x to the 2nd, y to the 3rd, and we're using the product property. And we're going to use it in reverse. So we have log b of 2 plus log base b of x to the 2nd plus log of b y to the 3rd. And remember, the 2 and the 3 can go in the front as a product of the log. So you have log of b of 2 plus 2 log of b of x plus 3 log of b of y. So we're going to expand this. We're going to have log of b, and we have x squared minus log of b, 2y. So now we're going to look at the first log, and you notice there's a 2 as a power that can be written as a product. So you have 2 times the log of b of x minus, I'm going to use brackets because I know that's a product there. So we have log of b of 2 plus log b of y. And there it is expanded. There it is expanded. So I'm going to rewrite this as a fraction. So this is 1/5. So we have log b, and we have x to the 3rd raised to the 1/5. So the 1/5 goes on the side as a product. And you have log of b, and we have x to the 3rd. And that 3 also goes to the side as a product. So it's going to be 3/5 log base b of x. So we have the cube root of y squared is equal to 4. So we're going to go ahead and we are going to raise this to the 3rd power, both sides. So on the right side you have 64. The root and the cube root cancel, so you have y squared. get the square root, get the square root. So y is equal to plus or minus 8. That's number 7. We're going to go ahead and subtract 2 from both sides. So you have negative 4 to the power x is equal to negative 64. Divide by a negative. So we have 4 to the power x is equal to 64. So 4 to what power gives you 64? And I'm thinking 4 to the 4th. Nope. 4 to the 3rd. Yes. So x is going to be equal to 3 because 4 to the power 3 gives you 64. So for number 9, you have to make it into a single logarithm. So you have log base 10 of 2x is equal to 5. What I would do here is write it as an exponential form. So you have 10 to the power 5 is equal to 2x. You want to divide by 2. So x equals 10 to the 5th power. 10 to the 5th power, which gives you 100,000. So it's 100,000 divided by 2. And we know that that's going to be 50,000. Okay. To solve this, I would write it in exponential form. So we know the base is 3. We know the power is 4 and is equal to x plus 1. 3 to the 4th. 3 to the 3rd is 27, so I'm thinking it's 81. It is 81. So you have 81 is equal to x plus 1, subtract 1. So x equals 80. X equals 80. That's it. So for this one, we're using natural log. So what you're going to do, you're going to write the natural log of e to the x is equal to the natural log of 5. And you notice that you have the natural log of e, that's the inverse property, so you're left with x equals the natural log of 5. And you don't have to evaluate that. You can leave it like that. I'm going to go ahead and do number 12 here. We have e raised to the x over 4 equals 5. So once again, you're going to write down the natural log of e raised to the x over 4 power. So you're going to get the natural log of 5. And this is the inverse property, so you're left with x over 4 is equal to the natural log of 5. You're going to multiply 4 to both sides. So you have x equals 4 times the natural log of 5. And these cancel here.